Yeah, so fetching your word from memory, how it is happening, we will see with an example. Move R1 comma R2. So move R1 comma R2, what happens here? So a read control signal will be activated in MA, that is memory address registers. Okay, so it will start the reading from this memory. Okay, from this memory bus, so it will start reading and it will wait for the memory function complete. So means it just retrieve MFC, memory function complete response from the memory, and after reading that it will load the MDR value, that is memory data register. So it will add the values, means your MDR will be activated and finally that value will be given to register R2. So these actions are carried out step by step. So if you see for completing all this it takes one clock cycle. So where except for these three actions, so it depends on the addresses and devices. So everything is completed in one clock cycle. Okay. So so this is one more example, fetching a word from memory. So as we already saw, so a read signal is activated at the same time. For MER is loaded. So after that, see it is R1 out. So after that, a read signal. So memory function complete will be waiting for this memory function control signal. So in the next clock cycle, we are doing the memory means MDR out. So we are transferring the data to register R2. So what these three steps are required for signal. So these three steps are very important for fetching a word from memory. So previously we saw a fetching a word from memory for an example. So but these is a common steps are used for fetching a word from memory. So common steps used. Okay. So next if you see, so execution of a complete instruction. So you can see here. So we are having instructions. So how with the help of the bus, so how we are doing the operations for, as I said, so we are having the instruction. So you can see here we are using this instruction add R3 comma R1. So what we need initially, it is a fetch operation, fetch the operand from the memory location and perform the addition load. These are simple steps, but actual instructions are actually in memory. How it is happening means, see, just listen carefully. So in step 1 what it is happening means the instruction register. Okay, so the instruction register fetch instruction register, it fetches the operands. Okay, means it loads the values in program counter. So program counter will be having the value, and from there the MER from memory address register it is giving. Okay, so it is why it is giving it to read. Okay, to read the values it is giving to the memory request. So I will repeat first step once again. So in order to fetch the data, the instruction fetch, that is first we are dealing with fetch, right? Instruction fetch. So the fetch operation, what it does, so it just loads the contents to program counter, from program counter to MER, that is memory address register, to read the data. Okay, so the select signal, so select 4 is nothing but the select signal, which what happens, the select signal, it goes the signals to multiplexer to select the value constant, which I already told why the 4 is why the value 4 is used. So after it is added the operand at input B, the value is given to one more value we are having, that value is also means parallelly we are performing here B and here A. Okay, so the constant 4 is given here to the multiplexer and that is given to A, and parallelly another value is given here in input B. Okay, and the results are stored in Z. So it's very simple. Okay, So from here, fetching operation program counter and MER in. So read the data and select 4 signals. A constant 4 is added for 32-bit, and we are doing the multiplexer does the 32-bit addition, and that value is given to multiplexer is gives the signals, and the addition is performed in ALU. So finally that is stored in Z register. Okay, so that is the understanding of the first step. So after that, what happens? The program counter in the this is everything is done in first clock cycle. So the program counter in step 2. Okay, the program counter in step 2, so waits for memory to respond. Okay, memory function complete. Yeah, W stands for wait. So W means wait. Wait for memory. Wait for memory function complete. Memory function complete. Okay, so this memory function this is in second cycle. Okay, so after that, in step 3, what happens? In step 3, the word is fetched from the memory to instruction register. So the word is fetched from memory to instruction register. So here memory to instruction register, the word is being given. So here first it is given like this, and from here it is like this. Okay, from memory to instruction register it is given. So after that, what happens? So after that, the contents of register R3. See here, you can see the contents of register R3 are given to memory. Okay, MER, and the memory is reading the values. Okay, so now so here it is waiting, and in step 3, so from MDR to it is given to instruction register. In step 4, what happens? In step 4 we are in step 4 we are transferring the R3 values to MER, and that is being read. So after reading, the contents of R1 are transferred to register Y. Okay, the contents of R1 are transferred to register Y, and the final addition operations, it is still waiting. So waiting for memory to complete the operation. So that's why it is given WMFC. So finally, after completing this process, when the read operation is completed, the memory operand is available in register MDR. So that the final value will be in register MDR. So that is given, that is selected, and adding the values, and finally everything is stored in Z out. Okay, so finally everything is stored in Z out value. That is the sum addition of the values are stored in Z out. The end signal. So after that, the control is transferred to R1 in. The control is transferred to R1 in. So finally the end signal is invoked, and it stops. That is, it just says the process over, and finally if it is still actions are needed, it will go to step 1 and perform the operation. So I will repeat this once again for your clear understanding very shortly. So in first step, what happens? So in first step, we are the instruction register. So instruction here it's given as decoder or register, you can say. So instruction registers gives the values to program counter. So the program counter will send the values to memory address register. Okay, memory address register with a read request. After that, the selecting a 4-bit. So here the constant 4 is selected, and that is added, and that value is given as an input to. So that values are given. Okay, that values are given as a result is stored in register EZ. That, and finally after that what happens in step 2? It is waiting for memory function to complete. In step 3, what happens? In step 3, we need to uh, we need to fetch the memory. We need to fetch the values to memory, that is from MDR, that is memory data register, to it is being given to instruction register RN. So after that, in step 4, what happens? In step 4, the register from R3, okay, the register R3, the data are transferred to MAR, and a memory operation, read operation is performed. Why it is happening means it need to read the values, and then finally it is giving input to R1. Okay, the contents of R1 are transferred to Y to prepare the addition operation. So because I need to add two values, right, as per this instruction. So which instruction we are performing? We are performing this. So only again we are moving here. Okay, after that finally what happens? So finally we are making that to out, and selecting that Y values, and final results are stored in Z register. Okay, and finally the control is given to end.